In trigonometry, we're going to be looking at triangles quite a bit. So today, we're going to be talking about some basic properties of triangles, as well as how to label the sides of a triangle if I wanted to focus on a specific angle. So for this triangle that I have drawn on the screen, I've labeled an angle theta down here in the lower left. That's my angle theta. And I want to talk about the three sides of that triangle specifically as they relate to my angle theta. Now, this is a special kind of triangle, being that it's a right triangle, meaning that one of the three angles in this triangle is 90 degrees. These are the types of triangles that we're going to focus on most at the beginning of trigonometry, as well as they'll come up, well, quite a bit throughout math if you go on even past trig. So yeah, right triangles. Again, they have the special property that one of the angles is 90 degrees. Anytime we have a 90-degree triangle, the long side is always going to be called the hypotenuse. That highlighted side there we call it the hypotenuse. Now the other two sides are going to be in relation to the angle that I'm talking about. The side that is opposite my angle, oh boy. So the side that is opposite my angle, we're going to call the opposite side. And the other side that connects to the angle we'll call the adjacent side. The angle in the lower left, and I called it theta. I switch to orange and look at this other angle up in the upper right, and I'll call it alpha, because we'll stick to Greek letters most of the time to label our angles. If I instead want to talk about the angle alpha instead of theta, that's going to switch the opposite and the adjacent sides, because it's actually this lower side that is opposite angle alpha, and it's this right side that is adjacent to angle alpha. So the opposite and the adjacent sides are all relative to which angle I'm working with. So we're going to use these sides to talk about some ratios that exist within triangles. Specifically, an oftentimes useful way to describe a triangle is to talk about the ratio of one side to another side within that triangle. And we're going to give special definitions or special names to a few of these ratios. So if we look at the ratio of the opposite side to the hypotenuse, we're going to call that ratio the sine of theta, or the sine of whatever angle I want to be talking about. If I were interested in, say, the adjacent side to the hypotenuse, again, the ratio of the adjacent side to the hypotenuse, that one has the special name cosine of theta. And then we're also going to have one more simple ratio, and that's going to relate the two sides, the opposite side to the adjacent side. I'm going to call that ratio tangent of theta. So sine, cosine, and tangent are the three most common, or the three basic trig functions or trig ratios, and they all talk about ratios of sides of a triangle to one another. So there's a handy mnemonic device for trying to remember these three trig functions. And that mnemonic device is SohCahToa. SohCahToa. That's just what's written up here at the top. So that first syllable, so, talks about sine. So sine is opposite over hypotenuse. S for sine, O for opposite, H for hypotenuse. So sine is opposite over hypotenuse. Ka, the middle symbol, cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And finally, the third syllable, toa. Or is that 2 syllables? Yeah, whatever. The third part of SohCahToa is toa. It relates tangent to the opposite side over the adjacent side. So those are the 3 basic, and the best way to remember that, again, is SohCahToa. There are 3 more that we'll talk about as well. And those are secant, which is the hypotenuse over the adjacent, cosecant, which is hypotenuse over opposite, and cotangent, which is adjacent over opposite. So these 3 are talked about a little bit less than the first 3. Sine, cosine, and tangent are like the main ones that we tend to look at, or at least outside of a trigonometry class. You'll probably only ever run into sine, cosine, and tangent if you run into any of them at all. But since we're going to look at all of them, we're also going to put secant, cosecant, and cotangent up here as well. So what else do I want to say? Each of these last 3 can also be defined as a reciprocal of one of the first 3, which is why they aren't quite as important. So for example, secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So anytime I talk about sine, cosine, or tangent, or any of the other 3, secant, cosecant, and cotangent, they all take an argument. And I suppose what I mean by that is that these are all functions. Sine, cosine, tangent, secant, cosecant, cotangent, they're all functions, so they all have to have something being put into them, an angle. So I always have to talk about sine of theta, cosine of theta, tangent of theta. Anytime I write out sine, cosine, or tangent, there should be an angle that goes into that function. So just writing sine by itself with no angle put in doesn't actually mean anything. Oftentimes throughout the course when I'm talking about stuff, I'll just offhandedly use sine, cosine, and tangent just because it's easier to say an angle into one of these functions. So you should be able to notice that throughout the semester, always be an angle attached to it. Because again, cosine by itself doesn't mean anything until I actually input a specific angle. But let's apply all of that knowledge. So, problem 7. Find the value of all 6 basic trig functions for each of the following triangles. So, those 6 trig functions are sine, cosine, tangent, and let's actually write them out as cosecant, secant, and cotangent. So if I say find the 6 basic trig functions, these are the 6 that we're going to look for. So it'll probably help to look at our triangle and identify which side is which. So once again, the long side is always the hypotenuse. The hypotenuse is going to be that one sitting up there. And then since this is in relation to angle alpha, which is down here, the opposite side is going to be 8, while the adjacent side is 15. So now that I have those sides labeled, finding the 6 trig functions is as simple as taking the ratio of those 3 sides in the order that I need them. So sine, I know, is opposite over hypotenuse. To actually put the fraction symbol in right now. That way I can use colors. So sine is opposite over hypotenuse. So 8 over 17. Cosine is adjacent over hypotenuse. So 15 over 17. And tangent is opposite over adjacent. So 8 over 15. Then cosecant is hypotenuse over opposite, or I could think of it as the reciprocal of sine. So since I know that sine is 8 over 17, cosecant is 17 over 8. Secant should be hypotenuse, 17, divided by the adjacent side, which is 15. And then cotangent is adjacent over opposite. So 15 over 8. And again, these are all reciprocals of, or these are all reciprocals. So each of the later 3 trig functions are all reciprocals to one of the first 3. So I could have also solved them just by taking the reciprocal or the flipped fraction of the first set once I'd found them. All right, then let's take a look at part B. Again, finding our 6 basic trig functions. So I want sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t. Let's actually inch these over a little bit. And I'll put those fraction marks back in. And I'll come back through and label my sides once again. So my hypotenuse, still in the same spot. It's the one that's opposite the right angle. It's always the longest side. Next, I think we labeled the opposite side in red, the adjacent side in green. Since the angle we're interested in this time, T is in that lower left corner. Let's move that out of the way a little. Okay, so if we go through and solve them again, sine opposite over hypotenuse should be 7 over 25. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And come back through and get the reciprocal identities. Cosecant's the reciprocal of sine. So 25 over 7. Secant is the reciprocal over 7. And those are the 6 basic trig functions.